All right, welcome back, my fellow aero nerds. In this video, we're going to be doing another tutorial on using GMAT. That's NASA's General Mission Analysis tool, not that test you have to take. And so this tutorial, we're actually going to be doing our first Hohmann transfer from one circular orbit about Earth into a different circular orbit about Earth. So we'll start out talking about what that Hohmann transfer is and what I'm talking about when I'm saying these different circular orbits and stuff. And then we'll get into the tutorial to show you how to set up this simple Hohmann transfer in GMAT. Let's get to it. Now, before we begin the tutorial, let's take a quick second to review what a Hohmann transfer is. I got a definition off of Wikipedia. You know, it's not always the best source, but it's got not too bad of a definition here, so let's use it. It says that the Hohmann transfer orbit is an elliptical orbit used to transfer between two circular orbits. As you can see here, we've got the red circular orbit and the orange circular orbit. The Hohmann transfer would be the purple elliptical orbit. And then going back to the definition, it says this often uses the lowest possible amount of propellant in traveling between these orbits. There is other orbits that sometimes use less, like the bielliptical transfer orbit. And, you know, we'll probably cover that in a future video. And of course, it's called a Hohmann transfer because it's named after Walter Hohmann. Now, these transfer orbits are needed when we're trying to go from a starting orbit to a final orbit, and those orbits don't ever have any points in common, right? There's not a point where you could be on both orbits. If that were the case, then we wouldn't need a transfer orbit. We can just do a simple burn to go from one orbit to the next while we're at that common point. But since we're starting on one orbit, we're going to a different orbit that don't touch, right? They don't have any points in common. It means we're going to have to do a first burn from that starting orbit to get onto a transfer orbit. And then when that transfer orbit comes into contact with the final orbit that we want to get to, we're going to have to do another burn to get off of the transfer orbit and to stay in that final orbit. And so this Hohmann transfer is a simple type of that, where we're going from one circular orbit to another circular orbit using a Hohmann transfer orbit, or this elliptical orbit. Now, what does that mean in the real world? That means usually one of two things. We could be going from one circular orbit to a different sized circular orbit around the same body, like you see here on the left. Some examples might be, you know, your launch vehicles put you up in a parking orbit, but you actually need to travel up to a higher orbit. Maybe you're going to the ISS, or maybe you're going up to a geosynchronous altitude, and so you got to get up to a higher orbit. So that's one kind that you see here on the left, and that's the kind that we're going to do in this video. Now, there is another flavor of this particular transfer orbit. You could start with a circular orbit around one body and then use the Hohmann transfer to get to a circular orbit around another body. I've got pictured here on the right, the first orbit is that red one that circles the Earth. And then you might perform your first burn to get onto that transfer orbit that will eventually take you to Mars. So when you get there, you'd have to perform your second burn to go from the transfer orbit into that final orbit around Mars. Now, this second type of problem is a little bit trickier because it's not just a matter of geometry, it's also a matter of timing as well. If I perform this maneuver, right, I start in my parking orbit, I perform my first burn, and I'm in my transfer orbit, and I get out to where my second burn is supposed to occur, and I didn't time it right, so Mars isn't even there, then that second burn's not going to do anything, right? It's not going to put me in a parking orbit above Mars because Mars isn't there. So with this type, we also have to worry about that timing. And you'll see what I mean in a future video when we do one of those Hohmann transfers. For the first step, let's go ahead and start the GMAT application. So look for a shortcut like this. When you start it up, it's going to open up the welcome page. You can go ahead and click that X in the top right to close the welcome page. Next step, we're going to go ahead and start a new mission. If you already had GMAT open and was working on something else, you can click this new mission button up on the toolbar. When you click that, it's going to do this pop-up that asks if you really want to load the default mission. Go ahead and click yes. And when you do that, you'll see here on the left in the resources tab, all of the stuff turned into the default stuff. So you got the default spacecraft, the default propagator, the default orbit view. Starting with the spacecraft, right click on default SC in the spacecraft folder. And when you right click on that, you'll see the menu pop up and we're going to click rename. And that's going to open up this window here with an edit text box. We're going to type in the new name. And so let's just go ahead and call that SAT1 for satellite 1. So type that in the box and click OK. Now that we renamed the satellite, let's go ahead and open up the spacecraft properties window. You can do that by double clicking on the object in the left project viewer window. We renamed it SAT1, so find SAT1 and double click on it. With the properties window open, you'll notice that it has a bunch of tabs at the top. Each of those tabs have a group of different properties of the spacecraft. For this tutorial, we're going to just focus on a simple orbit, and so we're going to stay here on the orbit tab and adjust those parameters only. In future videos, we'll cover some of the other tabs and properties in those tabs. So we're going to go ahead and start by updating the ParkingOrbit parameters. Here on the left, that would be the red orbit. This is the initial orbit that we're starting from. This might be the orbit you would get to after your launch vehicle takes you up to orbit. Or if you're a satellite and your orbit has decayed and you're about to perform a couple of maneuvers to get back up to the orbit you're supposed to be in, this red orbit might be your starting point as well for this particular mission sequence. So first things we want to do, let's go ahead and update the orbit parameters. We'll start with the epoch. Go ahead and change that to UTC Gregorian. And I just went and put January 1st of this year, just, for the heck of it. It doesn't really matter that much for what we're doing right now. And then going down to state type, I changed that to Keplerian. And so that changes the elements here on the right. And I can go ahead and update those parameters. I'm going to choose a semi-major axis of 12,756 kilometers. That's about twice the radius of the Earth. And then, of course, the other important thing is putting an eccentricity of 0. That's going to make our orbit circular. And then I went ahead and put an inclination of 25 degrees just for the heck of it. You could have left that at 0 or the rest of them at 0 too. Those don't really matter so much. The ParkingOrbit, the TransferOrbit, the Finalorbit, they're all in the same plane. So we don't have to worry so much about some of these values. So go ahead and update those values and click OK when you're done. The next thing we're going to do is we're going to add the first burn maneuver. This would take place when we're trying to go from the red parking orbit to the purplish transfer orbit that you see here on the left. To do that, right click on the burns folder and then find add and click impulsive burn. The difference between an impulsive burn and a finite burn is that an impulsive burn is just going to give you the entire delta V instantaneously. That has the effect of, when the burn occurs, of changing from the red parking orbit to the purple transfer orbit instantly versus a finite burn where, I don't know, for example, you might start the burn and it takes 30 seconds to achieve the entire delta V. So click impulsive burn and you'll see it show up in the left tree. Let's go ahead and rename this burn object. If you right click where it says impulsive burn in the tree, it will pop up this context menu and you can find the item that says rename. Go ahead and click that. That will open up this window here where you can type in the new name you want to call it and click OK. For this example, I'm just going to call this the TransferOrbit insertion. This is where we're inserting the spacecraft into the transfer orbit. So when you click OK, you'll see that it has the new name there in the Resources tab on the left. Now let's go ahead and double click on that TransferOrbit insertion burn in the left Resources column to open up the menu or the window that allows us to adjust its properties. And when that opens, we're going to go ahead and add the delta V that we want right here in the first box at 0.865 kilometers per second. As you can see above here, that's going to be in the VNB coordinate system. And so this first box corresponds to the V in VNB. That V in the VNB is going to be what you see here on the left. But for now, let's just go ahead and put in the value and click OK. All right, let's go ahead and create the second burn object. So again, right click on the burns folder, go to add and click impulsive burn. When you do that, you'll see it appear in the Resources tab on the left, right here, named Impulsive Burn 1. Now, the next step, step 9.5, is to hit the like button on this video. Now this is a very, very, very important step in this tutorial. Obviously, it's not going to work without it. Go ahead and hit that like button. Again, we're going to go ahead and rename this object that we just created. So right click where it says impulsive burn, and in the menu that pops up, click rename. And that window that pops up, type in Finalorbit insertion and click OK. This is going to be the second burn that we use to go from the transfer orbit into the final orbit. So that's why we call it Finalorbit insertion. After you type in that name, click OK, and you'll see it there on the left in the resources tab. Go ahead and double click on that Finalorbit insertion to pull up its properties window. When that appears, we're going to go ahead and give it a delta V of 0.725 kilometers per second. And as you can see up above, we're in the V and B coordinate system. And so we're giving this a delta V of 0.725 in that V of the V and B coordinate system. Go ahead and click OK. All right, so we've gone ahead and created all the objects that we needed on the resources tab. So let's go ahead and click over to the mission tab, and we're going to start building out our mission sequence, right? What are the order of the events that is going to occur with the objects we created? You'll see that it already has the default propagate 1 in it. Let's go ahead and rename that to ParkingOrbit. So right click on it, in the menu that pops up, click rename. In that window that pops up, type ParkingOrbit and click OK, and then you'll see that the name changed in the mission tab on the left. Let's go ahead and double click on that ParkingOrbit event in the mission sequence. And in the window that pops up, we're going to double click on these 3 little dots on the left to change the default stopping condition to be what we want it to be. So in this list, go ahead and find apoapsis. Just as a quick double check, make sure that that central body says Earth. We don't want to stop this at the apoapsis around, I don't know, the sun, which could be in a different part of our orbit. So make sure that says Earth. Click the arrow to move it over to the right as a selected value. When you've done that, go ahead and click OK. As you can see here in this propagate window, the stopping parameter has changed to be Sat1 Earth apoapsis, which is what we want. Now I'm going to go ahead and click this check mark to override the color for that segment, and I'm going to make the color red to match this drawing that I have here on the left. You don't need to do that if you don't want to. So after I do that, I'm going to go ahead and click OK to save the changes to this first event, right? This propagation event. So this first event took care of moving the aircraft on that red orbit, right? Propagating it on that orbit. Now it's going to stop at apoapsis, which is where I want to start the Hohmann transfer. And so what I'm going to want to do is that after that parking orbit, I'm going to want to insert this first burn. To do that, I right click on ParkingOrbit, go to insert after, and then I find maneuver and I click on it. And then you'll see that it will add this delta V maneuver in the mission sequence. It's called maneuver 1. So go ahead and double click to open up that maneuver, and you'll see that you have the option of choosing which burn that maneuver is. Since this is the first burn that's going to insert us in our transfer orbit, I want to make sure that I have the TransferOrbit insertion burn selected in that burn and click OK. So let's go ahead and rename this first impulse burn to TOI. This stands for TransferOrbit insertion. On that maneuver 1 object, go ahead and right click in the menu that appears, find rename and click on it. And then in the window that appears after that, go ahead and type in TOI and click OK. And you'll see that the name changes here on the mission tab on the left. Now, as I talked about before, the burn is an impulsive burn, and so it adds all of the delta V instantaneously, and so it has the effect essentially of changing from one orbit to the next instantly. You don't have to wait through a finite burn where it takes so much time to actually get all the delta V. Now, if you look at the mission sequence, and if we left it just right here, essentially what we're doing is we're orbiting on that parking orbit, and then we do the burn to change orbits, but we don't do anything. So if you went ahead and went play on the simulation now, you'd only see the red orbit. What we need to do is that now that we're on the transfer orbit after this maneuver, we need to actually propagate the spacecraft on this transfer orbit for a certain amount of time. So in the mission sequence on the left, go ahead and right click on the TOI burn. In the menu that appears, click insert after, and then we're going to go in the next menu that appears and find propagate and click on it. And you'll see it appear here in the mission sequence on the left. It's named Propagate 2. Now let's go ahead and rename it from Propagate 2. So right click on it, click Rename. In the window that appears, type in TransferOrbit and click OK. And then you'll see there on the mission sequence on the left that the name has changed to TransferOrbit. So go ahead and double click on that TransferOrbit to open the propagation properties window. And we're going to go ahead and change the stopping condition by clicking on these 3 circles on the left. And we're going to change it from elapsed seconds. We want to propagate this spacecraft to the apoapsis point of the transfer orbit. That's the idea behind this Hohmann transfer, is that we start at the periapsis of the orbit and we size it so that we get to the apoapsis of the transfer orbit when we're at that point where we want to switch to the final orbit. So find apoapsis in the list and make sure the central body, of course, is Earth. Don't forget to click the arrow to actually change the selected value there on the right column. And then when you do that, click OK. You'll see that the stopping parameter changed to apoapsis. Now I'm going to go ahead and do another step that you don't have to do. I'm going to go ahead and click this checkbox here to override the color for the segment. And then I'm going to search for this light purplish or pinkish, whatever color that is, so that when I'm on this transfer orbit, you can see that it's a similar color. And then when I'm done with that, I'm going to go ahead and click OK. All right, so in the mission sequence, we've went ahead and reached the apoapsis of the transfer orbit. And so now it's time to perform that second burn to insert ourselves into the final orbit. And so that means that we're going to have to right click on this transfer orbit, hit insert after. In the menu that appears, we're going to click on maneuver. And you'll see that that maneuver is added to the mission sequence. On the left, it's called maneuver 2. Let's go ahead and double click on that to open it up. And since this is the burn that we want to insert ourselves into the final orbit, we're going to make sure that the burn in the drop-down box says final orbit insertion. So go ahead and find that in the list, select it, and click OK. Let's go ahead and just rename this burn. So right click on maneuver 2, and in the menu that appears, find rename and click on it. And then in the window that appears after that, type in FOI for final orbit insertion and click OK. And then you'll see that it changed the name here in the mission sequence. Okay, so where are we right now? We just finished the transfer orbit. We're at apoapsis of the transfer orbit. We do the final orbit insertion burn. Since this is an impulsive burn, that means we just instantaneously changed from the transfer orbit into this orange final orbit. Now, if I stopped here and ran the simulation and showed it to you, you would see the red parking orbit, then you would see this purplish transfer orbit, but you wouldn't see this final orbit at all. And that's because now that we're on the final orbit, we have to actually propagate the spacecraft on that orbit for an amount of time to be able to see it show up. So let's go ahead and do that. Right click on FOI, and in the menu that appears, select insert after, and then in the menu that appears after that, select propagate, and you'll see it appear there in the mission sequence. Let's go ahead and rename this Propagate 3. So right click on it and click rename. In the window that appears, type in final orbit and click OK. And then there in the mission sequence tab on the left, you'll see that the name has changed. All right, let's go ahead and update the final orbit parameters. So double click on the final orbit in the mission sequence on the left, and you'll see the parameter window pop up. Now we're going to change the stopping condition by clicking the 3 buttons here on the left. I'm just going to go ahead and change it to be elapsed days, just because it's going to be pretty easy to just make it rotate for, I don't know, half a day or a day, just to get it to go around its orbit at least once so that we can see it. Doesn't really matter where it ends up. So go ahead and find in the list elapsed days and click the right arrow so that it becomes the selected value and click OK. You'll see that after I've done that the stopping parameter has changed to elapsed days. Since this requires some additional input, here on the right, I'm going to give it a condition of 0.5. So this is going to propagate the spacecraft on this final orbit until the elapsed days has reached 0.5. Which should be enough for a complete orbit. Now, I'm also going to go ahead and override the color for this segment as well by checking this box here on the left and then clicking on this color here on the right and finding the color I want. And so when I've done that, I'm going to go ahead and click OK to save the changes to this final orbit parameters. All right, we're done making changes and updating both the objects and the events that we want to occur. And so now comes the point where we want to actually run our project to simulate the mission sequence. So to run the simulation, you have the buttons here in the toolbar. You've got the play button, there's the pause button and stop button. And so if you hit play, then you'll notice that these two windows appear inside of the workspace area. And those appeared because we had them in the outputs folder, right? We had a default orbit viewer that we just did the properties for. Then we had the default ground track plot. After the simulation has finished running, we're actually able to animate the results to see the satellite travel over the ground track plot, or to see the satellite orbit around the Earth, to visualize the mission sequence. And we'll check that on the next slide. But real quick, there's also here on the top right, this GUI modified. This simply means that you've made changes to the script file using this GUI, but you haven't saved it yet. So before you close out of any of this, after you're done checking out the results, make sure that you save it if that's what you're wanting to do. All right, let me go ahead and pan around and zoom on this 3D plot just to try and get the overhead shot, make it easier to see. And then I'll hit this animation button a few times. But this is the final plot that we're going after. It's the same as that plot there on the left. And so it's really cool that we're able to add these burns in and be able to go from one orbit to transfer orbit to the next orbit and be able to model this Hohmann transfer. And of course, if you liked the video, thought this was a good tutorial and you want to see some more tutorials, don't forget to like the video. That's how I know that they're good and that you want to see them. All right, thanks for watching. I'll catch you in the next video.